3.3, that was the bell work problem, number 10, the DVDs. We're going to go on to page 134, and I'm going to bug you guys a little bit and have you guys tell me how would you solve, and I'm going to give you an example here real quick. And I'm having a hard time focusing here. This is out of my book. 2 times negative 4x, and this is similar to something you guys had, minus 13 is equal to 37 added to 13x. Remember, our goal is to get x on one side and a number on the other. So, starting with Miss Jewel, bug you back there. What do you think we can do first?
Multiply 2 by negative 4x.
Good. And
2 by 13.
Riley, stay with me, buddy. What's 2 by negative 13?
26.
Good. Keep following your equal signs down. So now we're here. What do you want to do next? What do you think? Hope, what do you think you can do next on this one that I've got on my... So you're adding your x's together, combining them. Very good. That cancels x's out here because the opposites add together to give you 0. On the left, you're left with negative 26 being equal to 37 added to 21 x. Now what? Mason, we're just going through some samples now. What do you think we can do now? Yes, Emmylou.
You subtract 37 from 36.
Bravo. You get negative 63, I'm believing. Last step in all this madness. What do you think? Ethan, finish it. 21. X is equal to negative 3. So even though it's big and bad, go nice and slow, one line at a time. And notice how I follow those equal signs and I keep them all stacked. Okay, that helps me later on. If I came up with an answer different than what I should have come up with, then somewhere in here I could potentially find my error. Okay, it's extremely helpful. Take a look at number 25 from yesterday. This one's right out of your book. Number 25, 4 minus 7 times a number is equal to 12 minus 3 times the number. Let's write an equation to represent that. Leah, what do you think you might say to represent what number 25 says?
Let's say, which right down?
Yeah.
4 minus 7 equals 12 minus 3.
Good. Very good. N, X, Z, Q, pick a letter. Okay. Looks to me like we have something going on. Now, I always want to keep my variables coefficient positive, so I personally would add my 7n over to the right, leaving me with 4 being equal to 12 plus 4n, right? What am I going to do next, Rach?
Like 4 minus 12.
We're here. Subtract 12 from each side? Okay, sorry. Got it. Negative 8 is equal to 4n. Last step. What do you guys think we'll do next? Go ahead, Rhino.
2 divide 4 by -8.
Negative 8 by 4 is right. So you should have come up with negative 2 being your value. To check it, you go back in, rewrite the equation, plugging in the value of 2 for wherever the variable lives, verifying in your calculator that that is indeed true. Okay? A lot of you aren't doing your checks, so on your homework I'm writing stuff like, where's your checks? And you're losing most of your credit. So if you're not doing it, nothing I can do. That's 25. Let's do the toll booth problem, number 27, everybody's favorite. So this is number 27, still on page 134. So we have something called an I-Pass here in Illinois, which is a little bit different than what they're describing. What they're describing is a tag that you pay a flat fee for that allows you to go through the toll for a discounted rate as many times as you want to go. But you got to pay for this tag up front. Okay? It costs you $24 to replace the tag. Here we go. You should be writing this down. You should be doing what you're supposed to do. So this is like the tag side of the universe, and I'll call this the non-tag side of the universe. So if I have the tag, it's 24 bucks just to have the tag. The cost of one toll, if you don't have the tag, is $3. If you do have the tag, the cost of the toll is $1.50. How many times do you have to have the tag and go through the toll booth in order for the count of the tolls to equal, or the cost of the tolls to equal what it would cost for you to just go without having the tag? So what they're saying is you've paid this flat fee, but now you go through for half the price. So if you add $24 to $1.50 every time you go through, at what point will it equal the cost of going through for $3 a pop? This would represent the equation that would allow you to solve for the X value, which represents times through the toll, times through the booth. So to solve, I'm going to subtract $1.50x from each side. And if I subtract $1.50 from each side, $1.50x, I have 1.5 times x being equal to $24. Now I can divide by that coefficient, and by dividing 24 by 1.5, x looks like it equals 16. Which means if you're only, let's just say this little tag is good for a year. Maybe you got to buy it every year. If you're only going to go through that toll booth twice a month, no, once a month. I don't know why you would do that, but let's just say you're only going to go through it once a month, 12 times per year. Then that would mean you'd be better off not even paying for the toll tag. But if you go to the thing this many times or more, you're better off buying the toll tag and then paying only $1.50. Okay? That's one way this type of thinking can work for you. The DVDs was another example of something like that. All right, this is the last one I have, and this is out of my book. All right. A bread machine costs $33. for one loaf, the ingredients all together, cost 33 cents. I know it sounds a little crazy, but we're gonna go with it. But in the store, one loaf costs you 99 cents. Same kind of problem as the toll booth problem. If I purchase the bread machine and make my bread home baked, machine and home, the expense associated with it is up front, I gotta buy the machine, right? And then every single loaf of bread adds 33 cents per loaf of bread. Whereas if I'm just gonna run to the store, then every loaf of bread is 99 cents per loaf. Okay? Like the toll booth, at what point will making my own, after having paid for the machine and such, equal the cost of me just buying loaf after loaf after loaf after loaf? To solve that, you find out what value for B will cause this side of the equation to equal this side of the equation. So to start with, we're going to collect all of our B's on the left. And you should end up with 33 being equal to 0.66 multiplied by B. I realize that numerically you think this all looks a little bit weird, but trust me, it does answer some stuff. After you divide by 0.66, you're going to find that bread of 50 loaves, once you've bought 50 loaves of bread in the store, you might as well have just started by buying the machine and making it yourself. The cost is now the same. What this tells us is, why should you buy a bread machine? Maybe you like that, okay? I'm not saying that. But if it's all about cost to you, and you tell me you're only gonna bake one loaf of bread in your entire time you own this machine, if you're only gonna bake one loaf of bread, then that one loaf with a machine will cost you $33 for the machine and 33 cents for the ingredients. One loaf at the store is only 99 cents, right? So either you really want to try a machine and don't care about money, or you might want to just buy them from the store because you're really blowing a lot of money. However, if money is the issue, then after 50 loaves of bread, having the machine and doing it from home will equal the cost of just going to the store. All other issues aside, the ingredients and all that kind of stuff. Okay? So this type of question can be useful to you to decide if it's all about money. If I know I'm going to bake 100 loaves of bread, or I'm going to buy 100 loaves of bread, let's just say it's for the bake sale at our auction. I'm either going to buy them or I'm going to bake them. Which way is cheaper? You're going to find out that for 100 loaves of bread, it's actually cheaper to do it this way. So you're better off, if you have enough time and the energy to bake, buy the machine. Okay? That's what this type of thinking allows you to uncover. That's the whole kind of purpose and all that.